Really? Yeah.
Can you find it? So just click on that link and log in the exact same way you logged in before. Sir, just click on that new link and log in the way you did before with your email, your OTC email to the Microsoft Imagine. Just click on that new link and log in just the same way you did before. It's not going to be any different. It's just a different name for the website, but you got it. You're smarter than it is. Maybe. Not supposed to say things like that. It's your fault. You see, he sent me that brain message. When you say something like that, you need to return further to the back. Cause me trouble. Where did we leave off here? Is that what it was? You want to go and do this homework on your own if you want to? Go ahead. It's fine. College teacher, not supposed to have to teach you guys anything. You're supposed to figure it out all on your own, right? Gosh, almost everybody came today. That's nice. We're still missing one in the back. That's going to be one sending me a bunch of sad emails. I'm so far behind. Hard. Guys ready? Last time we were working on methods, and you know, if you need some help with that REPL, because it does get a little bit more complicated when we get to more complicated stuff. That's the way things work, right? It's more complicated, so it will be a little harder. So if you run into trouble, you might need a helping hand. I see when I look at the REPLs, I see a lot of people submitting them without things being completed, but I never got an email asking for help. So remember, I'm not seeing those REPLs that you want help on unless you email me about it. Now, if it's after the fact, after the due date, the concepts that you're getting are important enough that I'll take it for partial credit because I still want people to complete them. What we'll see in our class is a big separation. So I'm seeing it already, and you guys might have noticed it too, is the people that work on the REPLs and get those things done move forward at a really brisk pace when we talk about new concepts in class and stuff, because these are foundation skills, right? And so the extra practice that you're getting helps you move forward really quick. The people that don't do them will have a lot of struggling because they won't have those foundational skills built. So do make sure I think everybody's doing a great job in here. I don't think we're having much trouble. We won't have a lot more of them because this methods one and then the one that is coming up available to you this week is about classes. The one about classes is going to require multiple files in REPL, and it just starts getting more and more buggy. So we'll get to a point where, especially when we get to graphical stuff, REPL can't handle that. So we'll be moving away from those completely. So do make sure and take advantage of them while you've got them to get those skills beat into your head as much as possible. I want to open Visual Studio. And with Visual Studio, I want to open that project we were working on last time. So our project should be Chapter 4, Method Practice 102. Mine's being kind of slow here. There it goes. Now let's look at this one. If you remember it from last time, let me check our attendance. I don't remember how many people we had gone last time. Let's see. Oh, just a few. Jesus God. All right. I'm going to paste this .cs file into the chat for our people that were gone last time. So if you're beside one of them, you try to help them as much as possible get a project created with this file. Okay, it's in the chat, our tester.cs file that we used. While everybody's getting that copied in, let's take a look at it. We started out with this one saying that we wanted to keep track of information about audio CDs. And so we're working for a store that resells things or whatever, but we want to keep track of information about CDs, albums, whatever media they might be. So we decided that in order to keep track of this information, first we would want to assign some sort of ID number to an album so we could find it in our store. Second, we'd want the name. Third, we want to know how many tracks are on it and what the cost is. Now, of course, we could keep track of a ton of other stuff if we were doing this for real, but we're trying to just get enough different data types in here to be good testing for us. So we don't want to add too much. We decided that we could personalize some of our messages if we got the user's name from the Windows environment. So we accessed an environment variable to grab that username, keep it in a variable in our program. Then we created some methods for the very first time, our new methods. Now our first method was the display instructions method, and we said this method requires input. It requires the user's name so that it can personalize the message that's displayed. So if we look at our display instructions method, further down, we'll see it didn't have a lot of stuff in it. It just writes out this message. So I have a question. The one line of code that it took to call this method, there's only one line of code in the method. Should I really create a method for that?
Yes.
Yes, correct. Why?
Because you might want to add some stuff later.
Exactly. This is a function, not an exact number of lines of code. The function is we want to display some instructions. So exactly, we might at some point come along and our users say, oh, we need 7 more lines of instructions there because that's not enough. Because what we're trying to do here with these methods is split apart logical items, logical things that don't belong with anything else. Nothing else in our program is worried about displaying instructions. So this method exists and is worthy even though it only has the one line of code in it because we could come along later and add to it. Perfect. So in our display instructions, we don't return any values back to the caller. The only thing it does is write out this message. Now after that, we call the input string method. And in our input string method, we said we're going to ask the user for a string. So if we look at that method, our input string method again accepts input of the prompt. We ask the user to enter whatever our prompt says, and then we return whatever we read in, because it's just a string. We don't have to worry about it. Now, looking at the rebels and some other stuff in hypergrade, I saw some people who replaced this whole message with that prompt variable. That's a great way to do it. That's a really good idea, too. So either one is fine. Then we went on and created, now we use that input string method for 2 things. First, we passed it a variable of ID to make that prompt say enter the ID. And then we passed it album name to make the prompt say enter the album name. When we called it using the ID as input, we saved the return value into our ID variable. When we called it asking for the album name, we saved it into our album variable. Now in our input int method, we had to do a little bit of validation. So we said that we were going to prompt the user for input, validate that input is an integer, and when they finally got us a good integer, we return it to our caller. So the last thing I asked you to do was to copy this input int method and create an input DEC method for inputting decimal values, because our cost variable is a decimal value. So if you look back at our hierarchy chart, we said our main method was going to call our display instructions, input string, input int, input decimal, and then display output. So we're here at our input decimal. Now an interesting thing, last week when I was watching people create this input decimal method, they weren't necessarily doing what I said. They were like, instead of copying this, they were creating this whole new method that did some sort of calculation or something. I don't know where that came from, but it wasn't what I was asking for. So let's fix it the right way so that we can use this the way we want. Now, some people did it exactly the right way. What we want to do is copy everything in our input int method. So I'm going to make sure I'm getting that closing curly brace and the method header. Everything in between. I'm going to copy that. And then after my closing curly brace, I'm just going to press enter and paste. Now right away I should start getting some errors. That's good. The errors I'm getting are going to say input int already exists, which is true, right? It's right above. So let's make this one be input DEC. Then my variable. Oh, look at all three of these places that say int should be decimal. So I'm going to change them. And if you wanted to, you could look at the Find Replace tool in Visual Studio and use it to replace them all. Now I've got the return value data type replaced to be decimal and my variable. The last place I need to change is in our while loop on our try parse, because right now it's still trying to validate that as an integer, and we want to validate it as a decimal. Now, is that everything? It should be. We changed, in our method header, we changed the name of our method and the return data type. Then in the method body, we changed our variables data type, our temp variable, and we changed the data type of our try parse. So not really very much to change there to get it to work for us. So let's do a save all. And then in our main, we need to add a call to this method. I'm going to put it right under our call for the number of tracks. We're going to set our cost variable equal to whatever gets returned from our input decimal method. And we want to pass our input decimal method just the word cost, because that's what we're asking for here is the cost. If you're ready, go ahead and try it. And you should see your prompt come up now for the cost. And you should see it display your cost properly when it displays everything. So now I'm getting a cost out. It would be nice if that cost displayed with a dollar sign and stuff. Let's fix that. Here on our right statement, I'm going to add the :C to our cost variable. Remember, this is our interpolated strings for this type of output. Remember that our non-interpolated are where we use the 0 and 1 and pass the parameter to replace. So lots of options for C# syntax. Everybody's work okay? Got a cost? Cost. Well, according to our hierarchy chart then, the only other thing we needed is a display output method. Right now, we have all of our output displayed here in our main. So we have the code to use, but we just need to move it and move it to a new method. So let's create that new method. I'm going to leave this code here for right now, and I'll go get that method header set up before I worry too much about it. Again, it doesn't matter what order your methods are in, but I'm going to put it as the last method, since display and output is kind of the last thing for our program. So I'm going to put my insertion point right here at my comment that was the end of our last method. Press enter to open up a new line to start my new method. Now, our first item that we have to put for a method header is the access level, public, private, whatever. We're defaulting to private, so we've just been leaving that off for this program. We'll continue doing that. For our next one, we'll start adding it. Now, we've seen that every method that gets called by our main has to be static. This method is our output, so it's not going to return any value. So I'm going to make its return type void. And then I want the method name. Do I?
Could you do it a string?
What would I return? You could, sure. If you wanted to do something with a string, yeah.
Isn't that what they're returning? No?
For this one, we're just going to print it out to the console, but we could return a string if we wanted to. So it just depends on how you want to do it. We're just going to copy this stuff that we already have, all these write statements. Let's cut them instead of copying. And let's put it down in here. We'll try it both ways. Now, our display output method needs a lot of input, doesn't it? It can't do a thing right now because it says, I don't know what any of these variables are. So we're going to have to give it some parameters. So the first thing that we need is a string to hold the ID. We need a string for the album name. And as you're typing these different parameters, we're going to put a comma between each one. So each parameter has data type name, data type name. So our ID variable will be a string that gets created just for this method. Our album variable will be a string that gets created just for this method. And we can keep listing parameters in this list for as long as we want, however many we need. Whenever we hit a comma, that's a good place that we could press enter and go to a new line if we want to, because things are getting too long. Now, as we type our parameter values, notice that our errors are disappearing. Now the compiler is like, oh, okay, you've got ID, it's going to be passed to you. And you've got album, it's going to be passed to you. So we still need an integer to hold our number of tracks, and a decimal to hold our cost. So whenever you're putting parameters in your parameter list, you could have one parameter per line if you liked your code the way it looked that way. You could always keep all of your parameters on one line no matter how far over it went. It's just totally a matter of preference for you. So there are no hard and fast rules about it, however you like it. But now we have this this method pretty well set. It looks like it's ready to run. Let's go back to our main and call it. So after we've got all of our variable data collected from our user, we're going to put in a call to display our output. Now we have a whole bunch of parameters, and if you look at the message from IntelliSense, it's telling you what all the different parameters are that you need to pass to this method. So the first thing I need is a string that's going to be my ID. So I'll say, well, that's ID. Next, if you notice the IntelliSense, it's bold now where it says album. So that's the parameter that we need now is another string. We did name that album. We need the number of tracks. And finally, our cost. Now in our program, at least for this method, we named the variables all the same thing. They don't have to be. We could name these anything we wanted in that method. Wouldn't matter. Okay, so now we should get some output. We shouldn't really see any difference, right? Because now we're using our display output method to output all that information. Let's run it and see. So I'm going to enter in my ID, album name. Let's say it's got 34 tracks. It's really long. Cost $10. Oh, we got our currency display, all of our information displaying right. Everybody's working okay? Good. Now, Terry was talking about what if we wanted to return a string? Well, first let's change our display output method to use a string instead of just doing all these different write statements. So to start doing that, in our display output, let's declare a string variable, and we'll just call it message. Now, instead of saying write here, oh, I want to set message to have an initial value of an empty string. So I'll use my two double quotes right together to be an empty string. So now I can just keep adding to my message variable. So just like we could do plus equal if we wanted to add to our sum, we can do that with a string variable. So I can say plus equal, and that's going to add more to this string. Now I need to take out those parentheses. So notice how our syntax didn't change a whole bunch. Now we're saying we want to add to our message, and we want to add in this interpolated string of a new line, this word ID, and then the ID variable. So let's do the same thing with all of our other lines. We'll just make it be message plus equal instead of write. Get rid of those parentheses because the write needed a parameter. And we're just doing a straight assignment statement now, so we don't need that. Message plus equal. And the IntelliSense editor is kind of helping show you what pieces you can get rid of. So now here, do I want to use a write statement to write out that message? Or do I want to use a return statement to return that message and write it in the main? What do you think?
Display output, That's true. If you were planning on doing anything with that output other than writing it, then you would want to return it because then you can return it into different
Like
variables.
build output or something like that.
Yeah.
Exactly, I think so. Because we didn't name it really in that way. And we'll be looking at doing that with our standard classes. So let's just go ahead and write it out here because we said we were going to display it. And now again, we shouldn't see any change in our output. It's really hard to think of this having a benefit over all those write statements. But every time that I write something out to the console, that's I/O, right? That's me saying, hey, user, I'm outputting this to you, respond to it in some way. So anytime we do I/O like that, we're potentially opening up a place where our program could fail because a user could do something weird to it, or we might not be able to find the console because of some hardware problem. So doing this message internally is actually safer because we're eliminating a bunch of unnecessary I/O to the console.
So even if they get interested in just like
Well, it's just that it wouldn't be hanging there waiting for them to press enter or something on timeout. So looks good. If everybody's got it, is it working okay? Let's talk about a couple of these things that we just did. Okay, so in this one that we were looking at, we created multiple parameters. And again, our parameters, when we define our method, we have to say what data type they are, and we have to separate them with commas. When you first start with C# or C# and Java, it can be a little bit difficult to remember that you have to include that data type. The IntelliSense editor will keep reminding you that it doesn't know what this is. Then when we call our method, we mention the method name and we just supply the data for those variables. We don't worry about the data type then when we're calling. So only when we're creating it. So here's an example that's a little bit different. We have 3 methods here. All 3 of them are called method 1. This first instance of method 1 returns an integer, and it doesn't have any parameters. Bless you. The second method 1 returns an integer, but it has a parameter of an integer. It expects an integer to be passed to it. The third time we have method 1 defined, it returns a string, and it expects a parameter of a string. Can we do that? Can we have 3 methods all named exactly the same?
Sure.
Sure? No? Yeah?
no,
Absolutely.
no,
Because the parameter separates them.
Exactly. So we can because they're different, right? How are they different? They have different return data types. They have different parameter data types. So all of those pieces are put together to make the unique method signature in C#. And that's a really important point.
So what happens if you call the method 1 integer and the method 1 and which one's called?
Say that again?
Like, what does the IntelliSense do? I'm wondering, I guess.
Well, if you were typing in a call to method 1, first of all, the IntelliSense editor would make sure that the data type, your return variable, was either an integer or a string, because it knows that those are the only possibilities. Then when it went to do your parameter list, and you're typing that in, is when it's going to decide which method is probably going to be chosen. But it's not actually going to be chosen until the runtime system is executing and evaluating it. And what it's going to do is pick the method 1 that matches your call. So if your call returns a string and sends a string as a parameter, it's going to say, oh, you want to run this version of method 1. But if your call expects an integer and doesn't pass any parameters, it's going to say, oh, it wants to run this version. What if your method 1 call returns a double? Compile error, we don't have one of those. So it would say, no, I don't know what you're talking about there. So your method is comprised of all of these things: the return type, the method name, and the parameter list. So all three of those things get put together to decide which method to call. And that's important in object-oriented programming because that gives us the ability to overload. To say, let's say I have a method that searches for an employee, like emp search. If you pass me a number, my emp search method is going to go find employee IDs based on this number. I'm going to try to find that employee that has that ID number. But if you pass me a string, I'm going to go search for employees by name. So I'm going to do different code depending on what data you pass. But my method name can be the same. So that's all used to create the unique method signature. So that method signature is what decides what the method is called, not just the method name. Remember that method name is a C# identifier. It's just built as part of that unique signature. So whenever we're encapsulating things, we're hiding details. We want to act as a black box. When we create a method, we want this method to do things, but we want our users to not have to worry about what it does. We want to hide that from them. They shouldn't care. Whenever we're using methods, we're creating modular programs. It's important. Remember, too, that each method should have a specific logical function, a purpose in life. This is going to help us make our code reusable and make it more understandable and maintainable. So as we work with methods, we're going to be looking at trying to use them somehow for beginning programmers. It's totally understandable. It seems easier to just have all our code in the main, right? Just do it all right there. I don't want to branch off and do these crazy methods because I don't know what I'm going to need there. It's all nuts. But it's a really important thing to get more comfortable with. So keep trying to do that, get things in methods. I know that it can be difficult when you're starting out. Let's take our tester.cs. I want you to right-click on it and choose View Class Diagram. Now, when I do that, it shows me this class diagram screen in Visual Studio. I'm going to have to click this downward facing triangle here to get it to show me anything important. Now, a class diagram is the beginning of documentation for our program. So in this class diagram, we see all the methods that we created for our tester class. I can stretch that out a little bit if I want to see more. And when we're looking at this visual, our program is pretty small really, but as we're looking at it, we could actually click on any of these method names and it would take us straight to that method in our code. So when we're working with someone else's code that we're not as familiar with, this class diagram can really help us a lot because we see how it's all laid out and what all their different method names are and everything. And as we get started looking at classes, it's going to mean a whole lot more to us. So this program, we created several different methods. We have our main method. We saw that anytime we call methods from a main method, those methods have to be static. So that means we can only have that method in memory one time. So for our program, for our audio CDs, how many of them can our program keep track of at a time? One, right? Because if we type in data for a new one, we're going to be replacing that last one. So we're not keeping any information for anything more than just one CD. So let's think about that as we look at stuff that is more class related. So I have this little program up. Let me run it for you. We're going to be thinking about class files themselves and object-oriented programming. So if I look at this sphere emitter, tell me about those spheres. They're emitting from the same point.
They're projecting into different directions.
They sure are.
And they're random colors.
Colors.
Semi-random colors. Yeah.
So let's think about the data aspects of them. You guys are on it. We know they have a different color. Do they have What can we say about that, where they're shooting out to? Is that like their direction?
Yeah, they random direction and momentum.
Direction?
Well, they only go out horizontally. Yeah, they don't come vertically at you.
Yeah.
They don't shoot at. No, I mean, they don't come at you, so it's only up.
They have
shoot
no-
at-
It's only going sideways or
Yeah,
way.
they only go and shoot on one plane. 2D, yeah, that's.
Yeah, they're doing 2D instead of
One
3D.
plane instead of the.
So we can fix that. What else about them? Do they have like a force?
Yeah, they have a gravity effect on them.
They're all the same size.
They rebound if
They're all the same size, but size could be like a data element for that, couldn't it? Like if we wanted to, maybe we could make some of them bigger and some of them smaller if we were expanding the abilities here later. Don't make yourself sick. They do collide. So they are collision objects. So that's all data. All of these data attributes that have to do with each of those spheres. So for every one of these spheres, you can think about it as having this kind of little Excel spreadsheet attached to it that's running along with it that says, oh, my color attribute is purple. My direction attribute is to the left, or whatever that value is for each given sphere. It's going to have to keep track of all of this data, right? Okay, then for all of the spheres, are there any actions that we could perform that you see all of them do? Emit, that's one, right? That beginning action, they emit. So let's say we're going to call that instantiate.
And then they fly off in one direction or the other, bounce around, and then eventually float off the screen.
So they move, right? And they don't care about where the screen is, do they? They're kind of dumb. So they don't have any very smart movement.
Well, as far as we know,
Yeah.
it may be that if the computer is efficient, that it destroys them if they get too far away. So
Oh,
that it's not
destroy. That would be a good action for us to take, right? We want to destroy some of them at some point,
so that they're not just flying off into the void and chewing up your CPU.
which is just getting ate up like crazy right now online, right? They're not being destroyed. So those are really good methods. There was a big line of them. So sometimes, what happened? Oh, they're just going nuts. Gonna see how long this machine can handle it. That white one is shot straight up.
Maybe
Yeah,
they're
there's
just
nothing in there
mystery
that makes
functional.
them different. It's just the gravity of Unity. So whenever we're working with a class, this is exactly what a class is. It allows us to create multiple instances of something, and for each of those instances to carry data and methods or actions that are appropriate for that class, right? So I need to keep them all together. If I have my blue ball, I want to know that it's blue. I can't be asking one of the yellow ones what color it is and expect to get blue, right? I have to ask the blue one. So each instance, each occurrence of those balls knows all of these things. It knows how to destroy and move and maybe instantiate, depends on how the code is. So a class defines all of this stuff, gives us our data, and then our actions or behaviors, depending on which book you're reading. But each of these things can all be pulled into this class, and now you could use my sphere class without knowing anything about it, right? If I gave it to you and I said, okay, if you want to instantiate a sphere, just type sphere and then tell it what color you want it to be or whatever other parameters, and you'd be able to use it and create it. So that's what's great about a class, is we can pull all this data and all of these actions together and put it together in a class file, and then it stays associated with that object, and we know what all data elements and actions that object is capable of. Yes, sir?
So the class is essentially a set of rules for defining what a particular data set might look like when you have a bunch of data sets that are going to be more or less similar.
I think so,
Not necessarily the same, of course, but pretty similar.
but similar. So, so think about students. A lot of the textbooks you read will talk about a student class. And if you've had a student class, what kind of stuff would you need? Their name, their ID, maybe their GPA, maybe their address, their birthday. Would I want to keep their age? I would keep their birthday, right? Because I can calculate their age. So those kinds of things that are associated with a given student, we would want in our student class. What kind of things would a student do? Enroll, register for classes.
Go to class, not go to class.
Those things. Attend, not attend, all of that attendance type stuff. So exactly, we can keep track of all of those attributes that have to do with each individual student through our class. Okay, I better make it stop because my computer's gonna crash.
Oh, it's crash.
You wanna see if it crashes? I don't think it will. It's getting pretty slow. It is slowing down a little bit.
I think it's getting rid of the message on the screen.
I'm disinclined to agree because it does seem like it's a lot less vigorous for like.
Doesn't it? Yeah, it's really slowing down.
That would have been a good idea, but I don't think that's what it's doing.
No, there's just so many
You just need to.
Yeah, because it's not destroying objects. It's keeping all of them. So it's pretty piled
You
up.
need to have a method in there that checks when it gets beyond this
Yeah.
ordinance.
That would be good.
Go ahead and destroy it because it's not going to be useful.
Do what?
Is there a way to change the perspective of the camera straight out?
Yeah, we could.
You should do it. You should make it straight out.
I'll tell all those people in Unity to fix it.
No, just
I'll
turn
just
the camera
close
so
it.
we can look down and see all of it.
No, you don't want to see them coming down. It'll make you sick. I'm not going to make you throw up today. Or me. You guys are going to make me throw up. My Unity project, iPad. You guys can fix it. But you have to download Unity to get it to run. Do what? Yeah, and it's not an executable. You'd have to use Unity. Okay, so cool. We see, I love Unity because whenever you're creating games, you see these objects so much more than what we see them when we're creating them with C#. Because all we can do is say, okay, we're going to keep track of this audio CD ID and its name, and we're going to print it out. But if you can really think about these objects as being visual, actual things like you see in that Unity game, it can be so much more meaningful for us. And it's all the same classes. So we want to make sure that everything is all happy with us. Okay, I'm getting cute little crap here. Here's our beautiful. Oh no. It's like Mr. Bill. Oh no, Mr. Bill. We squash him. Squash him. So encapsulation, we were talking last week about encapsulation being methods. How could I talk about encapsulation being classes? Just said that it was methods. Well, a class takes all of these characteristics about this object and hides them in implementation specifics from the users. Again, you don't have to worry about how to create a sphere. If you use this sphere class, you just need to know how to make it do it, right? Because it's all working and everything's happy there, so we can have that sphere class do its job. So object-oriented programming is based on this concept that we take the data and actions and behaviors of given objects and we make them into class files so that nobody else has to worry about them. We can take care of everything in the class file. Don't forget your encapsulation concepts. Remember with encapsulation, like with the phone, I'm saying I'm hiding all these internal pieces from the user so they don't have to know how they work. I'm decomplicating it, right? If you know how to work with that screen, then you don't need to know about any of those internal pieces. Well, that's great. It's nice that it hides that complication from us. But think about it from the other point of view. It also makes those things more secure. If we could touch them all the time, we would be all the time messing with the internals of our phone, right? Like, oh, if you connect this circuit to this circuit, you can make your phone go 40 times faster. Somebody read about it in Reddit. So everybody's going to be trying that, messing up their phone, right?
Yeah, but if I paid $800, I might mess with
You shouldn't mess with it. You're absolutely right. But if it was only a $49 one from Walmart, then I guess it's not that big of a deal, right? But either way, all of those internal parts are hidden from you. Look at that. Somebody's going to have to quit typing stuff. So all of those internal parts are hidden from you. So it's a secure implementation, not just an implementation that is less complicated for you. It's secure. All those pieces are secure now that we can't touch them. They really wanted them that way. They don't want us touching them. Here's our program.
Can we see what's inside of them? No.
Sure, if you open it up, void your warranty.
I do kind of think that the transparent cases could make a cut of that.
I was talking about the phone. I was talking about the classes and the program.
Yes, and we'll look at how you can see what's inside there. Because if you're using somebody else's, you need to know what those method names are and stuff like that. So
Whether or not they
you
hid
can,
something in there.
right, and it's kind of like your phone. You still need to know how much space does it have, those kinds of characteristics of it that we can't change but are internal to it. So in the same way, yeah, we'll be able to look at it.
You don't necessarily need to know how the different functions work, but you need to understand how you use them and what they do.
Yeah, what they are. Okay, so we've had this hierarchy chart since last time. We have our main. Our main calls all these other methods. Now, I've had some programmers over the years that did things a little different. So tell me, what if you saw someone who coded it a little bit differently and they had their display instructions call input string, and then they had input string call input int?
We would bully them and make fun of them.
Good, that would be a good first step.
All right.
And then you had input desc. And then finally at the very end, this last output one. So
I see no problem.
bullying may be a little tough of a term, although he's correct. Why? What's wrong with this? You say, see nothing wrong with it. It works. So why is that so awful? Because it is awful.
If one fails, then the whole thing fails.
You gotta go from one to the other to the other to the other. You can't just skip.
We have a lot of dependencies there, right? So whenever we're looking at dependencies, you guys know that. If you're dependent on this friend to pay you some money for your rent, and you're dependent on this friend to pay you some money for food, and you're dependent on this friend to pay you some money for gas, what's the likelihood of you having enough money for rent, food, and gas?
Depends on how reliable your
Depends.
Sounds like you're a mob boss.
How many dependencies should you have? You want to eliminate dependencies wherever you can, right? So whenever we're making this, you guys are exactly right. We're saying the input int is dependent on the input string working, which is dependent on our display instructions. But some other people said, how do you find it? Which is also a really good point. It's buried way down in here. So the fact that we do things across like this is totally just one way of doing it. You could do it this way. It's not as good of a way because it is more error prone. It does hide code from us, does make it harder for us to see what's going on, but it's possible. Do what?
You take something out and plop one function out, it just don't work.
Right, you've just totally increased how everything's all mixed up together.
Or if, like, you need to add something where you got to
Yeah. It is just not as maintainable as doing it this way. So just a way to think about, because sometimes that does happen, is people are thinking about code too. They might end up with that sort of solution. All right, so our program, we decided that we wanted to take care of audio CDs. So we implemented an audio CD inventory program. We can input info about a CD and then display it, right? That's what our program does. What if we want to save information about more than one CD? We can't. The way our program is right now, every method in there is marked static. And remember, that's the #1 rule about static. I can only have one instance of that method in memory. So if I have static methods, I can only have one. When I type in information about a new CD, it's going to replace the old one. I'll only have one at a time. But if we use a class structure, like what we had for the sphere, then we would be able to keep track of all sorts of CDs at the same time many instances of CDs that we could have all built together. So we're going to take our program and implement it as a class structure so that we can have more than one. So the first thing we want to do, take lab time, is we're going to create a small class, and it's only going to have one method. It's going to do a calculation. Now this method is just going to calculate our value. In our CD scenario, we have the cost of our CD and the number of tracks. So we're just going to do some sort of weird calculation with those numbers and say that that's our value, because we can just make it up. We don't have any accountants or anything telling us what the right formula is. So we'll just make up a formula, and that'll be our very first class that only has this one method in it. So let's try it. I want to create a new project. Now, I had you guys open this class diagram. When you close it, Visual Studio is going to ask you if you want to save it, and just say yes. Now, once you say yes, if you don't give it a name, over here in your Solution Explorer, you'll see that class diagram, and you can click on it if you want to bring it up and look at it again. And like I said, it'll get to be more important in our new projects where we start working with classes. So class diagram, close it. So really, we're all done with this project. I'm going to close out of it completely. Chapter 4, we didn't have a lot of practice with methods, but more so than some semesters. Let's save all that. And I'm going to open Visual Studio and create a new project. So our new project, let's make it, I'm going to make the solution name be Chapter 5 Audio CD Basic 102. And then I'm just going to name this first project Audio CD Basic. Now, whenever you're ready, let's just click OK. On Canvas, you don't have to go there now, but if you look at the announcements, well, hang on, I'll get there. If you look at the announcements, there is a link to the GitHub repo that has all of the source code for our book, our textbook. So if you download all of that, I noticed with Chapter 5, they just give you little teeny pieces of code, but they have the full project in their source code. So if you download those as you're reading through the book, it might make it more meaningful, because it actually does show you you can see the whole project instead of just a piece that they show you in the chapter. So that was kind of buried in our textbook, so I just was wanting to post it for you guys. All right, let's take a look at our project here. I have my new program, and for this one, what I want to do first is copy everything from our old program. Lots of ways we could do it, but I think that I'm just going to open Visual Studio again. So I'm going to right click down here on the taskbar and open Visual Studio again. I'm going to open our Chapter 4 method practice project. And while I'm looking at our tester.cs, I'm going to copy the whole thing. So I'm going to Control A to select all, Control V to copy. Oops. I'm going to try that again because obviously hit something wrong. How about Control C to copy instead of pasting? All right, once you've got it copied then, in our new program, first thing we need to do is rename our program.cs to be tester.cs, like we'd named the other one. Now that I have them the same name, I'm going to Control A in this file because I don't want to leave any of this stuff remaining. I want to completely wipe it out, and then I'll paste. So if you do that, you shouldn't have any errors when you get this code all pasted in Visual Studio. Okay, everybody? Need any help? I know. Now, to make sure everything's good, you should be able to run it. Should work exactly the way it did before. Get everything there the way we want it. Perfect. Is it all working? Get it? Got it? Got it? You're good? You're good? Now, we have a little bit mixed up in this program, a little bit that belongs in our audio CD class. We're not going to worry too much about that right now. What we're going to do first is create our audio CD class with just the one method in it. So let's create a class. Now, when we're in a project, it's really easy. I like to use the Solution Explorer because if I right-click, it's a visual for students to see, right? So if I use keystrokes, it might be hard for you guys to know what I did if I don't say it. But on my audio CD project, I can right-click and choose Add Class. That's one way to add a class file. Now I also, if I'm clicked on my audio CD basic project, I could choose Project, Add Class. That would do the same thing. And notice that it also has a shortcut, Shift-Alt-C. So do any of those things to add a new class file to your project. And we want to call our new class file Audio CD. Classes in C# are normally named starting with an uppercase letter. So we use camel case, but it's normally upper camel case where we start with an uppercase letter. A lot of other programming languages start with lowercase letters. C# likes to be a little different. Okay, once we've got this audio CD in our name, we're ready to click Add. Now we should end up with a brand new .cs file in our project showing up in our editor screen, ready to do some stuff with. So I'm going to zoom in here on this. For our audio CD, we only want this one little method. And what's weird is we're going to make it actually a static method. Now, since we're working in a separate class, we're going to have to put in that keyword public. Our method won't be accessible by our main unless it says it's public. Now, we could use protected and some of those other ones also, but we'll just go with public. Now, we are going to make a static method for this very first one. We're going to say that it returns a decimal, and its name is calc value. Now our calc value method is going to accept two parameters, a decimal parameter for the cost and an integer for the quantity. Oops, sorry. The integer is going to be the number of tracks. Oh, it's getting us fancy. Now when I have that method header typed, I can put in, well, let's look at the error message first. Right now I'm getting a terrible error message. It says your method must declare a body. Oh, okay, so I need my curly braces. That should get rid of that error. Now I still have an error on my method name, and it says not all code paths return a value. That's true. I don't have a return statement in here yet, so I'll live with that error, and we'll fix it here in a sec. So let's return a value. what we want to do is take, let's see, our cost times, how about num tracks, I don't know, times 0.2, and that's going to be our cost, our value. It's got an error. What's wrong? Looks like a valid calculation to me.
Because you can't put a decimal and an integer together.
Decimal and double.
Well, all of mine are decimals and integers. So which one is a double? The 0.2 would be what?
0.2 is the double.
Would be the double. You're right. The 0.2 is our double. So what we can do is we can put a modifier on there, the letter M, to say you're a decimal value. And that clears up all of our errors. So remember when you were up here and you're going, I worked on that thing for 4 hours and it was one stupid letter. I understand. I do know. Welcome to programming. Exactly. I'm so proud of you that you would put that much into it because that's what it takes. But yes, the one letter.
Maybe it makes sense. Maybe it would be a D for decimal, not M.
And for money. Because decimal is like money. I don't know. I just made that up. But that's what I came up with.
It makes
Yes.
sense. You really have to put the parentheses after. Is that one? Like that's purple, right? So it's not.
The parentheses, for my silly formula, I decided that's what my formula is going to be.
But like, do we have to put it all in one after the return?
No, but we could.
Just
Wanted to.
the order of operation.
Yeah, so we could if we wanted to, like if you want to put that whole calculation in parentheses. And a lot of people like that, just the way it looks whenever, if their return statement is only a calculation. A lot of people like to put it within a set of parentheses like that to kind of emphasize that that is really what they mean to do, you know, just this calculation. So yeah, that's fine. So yeah, this is kind of a bogus formula. We're not going to get a reasonable value out at all. But I wanted to show you how when we're crossing different data types like that, C# can be a real bear. And it's usually as simple as finding out what the modifier is to change that data type on one of the values. And remember, if we go back to the beginning of Programming 101, our 0.2 would be better off in a constant variable, right, that never changed. And I would still have to do the same thing in the constant variable with the M to make it take it. So either way is fine. Okay, so now we have this class. That's all we have in it, is our calc value method. Are we ready to call it? Let's try it. Now I want to go back to our main method. And usually in C# when someone says their main method or their main class, they just mean the class that has their main in it. So in our case, that's our tester class. Now, one thing I'm noticing right away has to do with this blue underline. I'm not going to fix it though, so I want you guys to see what it does. All right, so I'm going to start out at the top in our main saying, okay, we need a new variable to hold this CD value. Whenever we get done getting our cost, we're ready to calculate our CD value. So I'm going to put a call into our new class method right after that. Now our class name is audio CD. But it's like it's not being very nice. It's saying, I don't know what that is. You must have something wrong. Well, it's right, we do. But notice how it's not being very helpful. Our problem is our namespace. So since we copied this code from our previous project, we got the namespace from that previous project. When we created our new auto CD class, audio CD, it got the namespace for our new project. I need them to be the same. So I'm going to go to my audio CD class and copy its namespace value. And then my tester, I'm going to paste. Yes, sir.
If I'm following along correctly, it sounds like the namespace tells Visual Studio or whatever, lump everything that has this particular namespace in together, please.
Yeah, they're related. They're related.
They're related, but in separate files.
Uh-huh, exactly. So now when we start typing in the name of that new class, it should recognize it for us. Oh, there it is, right at the top of my list, audio CD. It knows that class now. And I see that it's changed it to a nice aqua color. So I'm going to do audio CD, and then when I type the dot, it shows me all of the methods that are available for my audio CD class. And there's only one, the calc value. So I'm going to execute that. Now the calc value is giving me an error because it says calc value expects two parameters, one that's a decimal cost and one that's an integer, your number of tracks. So I'll put in my cost and my num tracks. Now we want to add that to our output. So in our display output parameter list, I'm going to add that CD value variable. Now I'm going to get a bunch of errors because our display output isn't expecting that yet. We haven't updated it. That's what we're going to do next. So now let's go to our display output. And at the very end, we'll add more to our message to say that it's going to output the CD value. I want that to be currency. Oops. Now, anytime IntelliSense starts doing weird things like that, it's usually because it's not finding what you're typing. And that's because I didn't add it as a parameter yet. So I want to do things in the right order, add that CD value as a parameter, and then when I try to use it, it'll be much nicer to me. And I can format it as currency and put my semicolon. Now, when we added that in, we could have just come to our display output method and put in a call to that calc value, right? And just displayed that value here. So did we need to put it in our main and then put it in our parameters to call this and come down here? If we would have just stuck it in our output, that would have been fine. It would have worked, but it would have been kind of the lazy way to do it. And again, if we had to go back and do something else in that method, we could end up having trouble because it wasn't integrated the whole way through the program like it needs to be. Now, if you've got those in, let's try it, and we should see it all working. So I'm going to enter my ID. I'll do number of tracks, 34, cost 50. This is going to come out with a really wrong number. $340 CD, that's what we want, right? So it did something. So let's create some class diagrams. In your audiocd.cs, let's right click and choose View Class Diagram. If you expand that, you should see that our audio CD class only has the one method. Now I should be able to add the tester to that. I can right click and view class diagram, move it out of the way, expand, and now I should be able to see the way each of them is set up physically, their structure. Now, I don't see the connection between the two. That's all right. The class diagram doesn't show logical. It just shows functional connections, which one is called by another. So that looks great. Now let's go back to our audio CD and our tester and put some comments in. So it's grading. You guys are doing a great job with your comments. I want to start out with our tester class. And right at the very top, I'm going to press enter to open a new line and do the 3 slashes so I can generate those XML type comments. I'm just going to put something overview in here. This class tests our application. Now for our main method, we'll put something like the main method is the program entry point. Bless you. Now let's go down. We want to put a comment for, we already have one for our display instructions. Pretty big one because we were looking at things there. So let's add a comment for our input string. 1, 2, 3 slashes. C# automatically opens up window with the XML header stuff already in there for me. So let's just put something really basic. This method prompts for and returns a string. Whenever the IDE put in these nice XML comments, notice it gave us a begin tag and an end tag for parameters, and they're all listed in there. And it gave us a begin tag and an end tag for what kind of things this method returns. It doesn't try to fill that out for us. So we could put something there within those 2 words. We'll put this one returns a string. Now, when you guys turn stuff in, the comment points come from having the main comment up top. So let's put our name and everything in there. I'm going backwards. Because these comments are the only ones that I'm going to count off if you don't have. And you guys have been doing a really good job at getting them in there. Other class, not so much. So I'm just going to say something like our purpose is to test an audio CD inventory. So you don't need to have comments on every single method. I'm not going to count off if you don't. But that would be the best. Now, students that have gone off and gone to work, I know some that work at some of the bigger companies in Springfield are mandated to put a comment for each method. Other people that work at some of the smaller companies are not. So I'm going to keep going though because I want you to think about it. Now our input int, I could say this method prompts for and returns a valid integer. Now I can do the same thing for my input DEC. This method prompts for and returns a valid decimal. Lastly, for our display output, this method outputs audio CD info. And of course, if we had any really complicated logic or anything in any of those methods, we would want to say something about that. But our methods are pretty straightforward. So now our audio CD class, let's go to it. Again, at the top, I can document my class. And we were talking last time about how this establishes your ownership, your intellectual ownership of this intellectual property. Because if you ever are in court trying to prove that something is your property, these kinds of things are used as evidence to say, look, I wrote this program 5 years ago. I have comments in my code. It was obviously my program. It hasn't been changed in that time. And they're going to look at all sorts of different things like that to decide who actually has the ownership. Now I'm going to put a comment for our calc value. This is the static method that calculates value. So because this one is a static method, we were just able to call it directly from our main. So it looked like almost like we were calling just any of our other methods, but this one was off in some other class. So we were going to really focus on that and think about how that makes it different. Okay, so we have commented up this thing like crazy. Next time we're going to make our audio CD class much more robust. We're going to add data to it and our other methods so that it does more than just calculate the value of a CD. But the way it is right now, with this weirdo calculation, we've got that hidden from others, right? And if we wanted to have another application, say we had an inventory application that was keeping track of DVDs or whatever, they could make a call to our same method and use it. So we'd start being able to get that code reuse that we're looking for. That it stands alone because it's in its class, but other things could call it. Questions about that one? It's a good first example for using classes. Happy guy there. There is a new REPL this week. And of course, I already went on and on about how they'll be getting a little bit less often. So let me know if you have any trouble with it. One thing that I noted over here on the side of the board, I don't know if you, I have a couple of special projects. If anybody has time and would like to do something special, I have a bunch of new Raspberry Pis that need to be set up. So we need SD cards installed and things like that. And over the weekend, I started trying to create really short video walkthroughs for the different REPLs. If you go back to the one about looping, you can see some of those short videos that are just real quick YouTube walkthroughs of how to finish this REPL. If you would like to make some videos of how to finish some of those REPL assignments and send them to me, let me know, because there's a whole bunch of them and I could sure use some help because I'll stay behind and never get caught up for us this semester. So send me an email or something if you can help with either of those, and I'll figure out a way to give you some extra credit or whatever it is that you would like to do. Any questions before we stop? All right, lab time. Got some REPLs. Get out of here if you want. Work on your assignments, whatever you would like to do.